Good morning, students. Welcome to the lecture session on partial differential equations. Today we are going to discuss some of the topics, that is integration tutorial problems. One is the direct integration method. In this one, direct integration method already I have explained. So some more problems I'll be explaining in the today's class. Dou square z by dou x into dou y is equal to x square y, and it's given that initial condition what they have given is the z of x comma 0 is x square, and dou z by dou y of 1 comma y is cos y. This is what has been given. Now dou square z by dou x into dou y is x square into y. Let's call this as equation number 1. Now integrate this with respect to x, treating y as a constant. So in this one, once we need to integrate to get the value of z, once we need to integrate with respect to x and once with respect to y. First let us integrate with respect to x, treating y as a constant. Later we will integrate with respect to y and treating x to be a constant. After getting the integration, that is z value, we will be having some constant function as one as a function of x and another one as function of y. To obtain those, we need to substitute the initial condition, that is z of x comma 0 is x square and z of dou z by dou y of 1 comma y is equals to cos y. These are the two things we need to substitute so that we will be able to get the function of y as well x. Now integrate y treating x as a constant. Then we will be getting this z is equal to x cube y square divided by 6. Previously we have done the integration with respect to x treating y as a constant. There we got it as dou z by dou y is equal to integral of x square is x cube by 3 into y plus the function of y, which is a constant, as added. The next we will integrate y with respect to y treating x as a constant. There we get z is equals to x cube into y square divided by 6 plus a function of y, that is integral of f of y. We will call this as capital F of y, and g of x, which is integration constant for x. So we have f of y and g of x, which has to be determined. In order to determine these two, let us put x in the equation 2. Then that is x is equals to 1 in the equation 2. So we get it as cos y is equals to y by 3 plus f of y. From this equation, what is f of y? F of y is cos y minus y by 3. Then now the capital F of y has to be determined. That capital F of y is nothing but the integral of f of y into dy. That is, we need to integrate this with respect to y only. So what happens? Integral of cos y minus y by 3 into dy. And we know that integral of cos y is sin y and y is y square by 2. That gives us y square by 6. Therefore, we are getting capital F of y is equal to sin y minus y square divided by 6. Next, put y is equals to 0 in the equation 3. We get x square is equals to 0 plus g of x. That gives us g of x is x square. Substituting the arbitrary function value in 3. Then we get z is equal to x cube y square by 6 plus sin y minus y square by 6 plus x square, which is the required solution. Next, one more problem let us do, that is derivative with respect to one independent variable. So with respect to one independent variable means we have to convert it in terms of only one independent variable by suitable substitution. Solve this. Dou cube y by dou x square dou y minus dou u by dou y is equals to 0. Given that u is x square by 2 when y is 0 and dou u by dou y is 0. Dou square u by dou x dou y is y when x is equals to 0. This is the given condition. Let us consider the given equation, that is dou cube u by dou x square dou y minus dou u by dou y is equals to 0. Call this as 1. In order to reduce it to the single variable, what we need to do is we need to do a substitution, that is dou u by dou y we will put it as v. Then what happens? It will become dou square v by dou x square minus v is equals to 0. And we can observe here one dependent and another one is independent variable. And we can consider it as a ordinary differential equation. Then it will be like d square v by dx square minus v is equals to 0. We get it as d square minus 1 of v is equals to 0. So auxiliary equation will be, by replacing capital D as m, we get it as m square minus 1 is equals to 0, which on solving or finding the roots we get m is equals to plus or minus 1, that is real and distinct. Whenever we are having a real and distinct roots, we can write the ordinary equation solution is v is equals to c1 e power x plus c2 e power minus x. But c1 and c2 should be replaced with f of y and g of y. And even v is also replaced with dou u by dou y. That gives us equation 3. Now integrate the 3 with respect to y, treating the x as a constant. Then what happens? U is equals to capital F of y into e of x plus capital G of y into e of minus x, e power minus x plus h of x, which is a constant of integration. Now, where capital F of y is integral of f of y dy, capital G of y is integral of g of y dy. Now differentiate this 3 with respect to x partially. We get dou square u by dou x dou y is equals to f of y into e power x, because capital F of y integral is, derivative is small f of y into e power x, and similarly capital G of y integral is this one. So we are getting this one as minus g of y into e power minus x. We are differentiating 3, not the fourth one. So this is what we will be getting. Now we can substitute the condition. So put x is equals to 0 in 3 and 5. We get it as 0 is equal to f of y plus g of y. And next is y is equal to f of y minus g of y. Here we are getting the two functions with the two equations, which can be solved as a simultaneous equations for f of y and g of y. First let us add the two equations, then g of y and g of y cancels. We get 2f of y is equal to y, or f of y is equal to y by 2. And similarly when we subtract this minus this, that will be g of y is equals to minus of y by 2. So when we integrate it, what do we get? Capital F of y is integrated, that is when we integrate the small f of y with respect to y, we get capital F of y, that gives us y square by 4. Similarly, g of y when integrated with respect to y, we get the capital G of y, that is giving you minus y square by 4, and this is plus y square by 4. Next, put y is equals to 0 in the equation 4. That gives us x square by 2 is equals to 0 plus h of x. That is, h of x is x square by 2. This is what we will be getting it. So the equation 4 is implied as u is equal to e power x into y square by 4 minus e power minus x into y square by 4 plus x square by 2. And from the first two terms we can take y square by 2. There it reduces to e power x minus e power minus x divided by 2 plus x square by 2. And we know that e power x minus e power minus x by 2 can also be written as sine of hyperbolic function, and therefore y square into sine hyperbolic plus x square whole divided by 2 will be the solution. That is the required solution we are getting it. Thank you.